Okay, continuing on the portion we stopped, which is actually doing the example under geometric sequence, which is example 14. Let's try to continue on that part by solving this example. So the problem is up to how many terms of the geometric progression 3, 6, 12 must be added to get the sum of 381 and identify the terms. So basically, there are two things that we need to do. First one is uh, we have to find yung ano niya, yung pinaka what do you call this one? Yung number of terms. Tapos after which we have to identify those values. Okay? So let's try to do that. So for this case, for a solution, we could actually make use yung ating formula for the series or geometric series. So for this case, based on the given sa problem, I'd like to make use ng ating um, what do you call this one? I like to make use ng ating formula na S sub n is equal to A sub 1 times 1 minus R raised to n over 1 minus R. Kasi meron tayong A sub 1, which is going to be 3. Tapos we also have our S sub n, since we do not know up until what term would that be. So S sub n is 381, or the sum of the terms. And then we also have yung ratio. So yung ratio there would be determined by dividing yung ating mga succeeding values or succeeding terms. So 6 divided by 3 is 2, and then 12 divided by 6 is going to be 2 as well. So therefore, our common ratio is 2. And then I think that's just the things that we need to calculate for the n. So if we make use of the formula, it would be now S sub n is equal to A sub 1 times 1 minus R raised to n divided by 1 minus R. Tapos, we substitute the values now. Yung S sub n is 381. And then, yung A sub 1 there is 3 times 1 minus 2 raised to n. Tapos, divide natin siya ng 1 minus 2. And then, if we continue on calculating, it will be now 381 is equal to 3 um, times 1 minus 2 raised to n, and then divided by 1 minus 2, which is negative 1. And then we try to simplify the value, no? So 3 divided by negative 1 is negative 3 times 1 minus 2 raised to n. And then we could divide both sides by negative 3 as well to isolate yung ating 2n, negative 2n. So if we do that, 381 divided by negative 3 is how much? So 381 divided by negative 3, 381 divided by negative 3 is negative 3. Divide 381 divided by negative 3. Bakit nag-ano siya? 381 divided by 3 na lang, which is 127. So that's going to be negative 127. And then equal to 1 minus 2 raised to n. Tapos if we continue, it would be now negative 127. Negative 127, we transpose 1 to the other side of the equation. It would have negative 127 minus 1 is equal to negative 2 raised to n. And then negative 127 minus 1 is negative 128 is equal to negative 2 raised to n. And then we divide both sides by negative 2. I don't know, we do not divide, but we express yung ating negative 128 into 2 raised to n. But before we do that, we divide by negative 1 pala to make it positive. So negative 1, we divide both sides by negative 1, so it would be 128 is equal to 2 raised to n. And then what we are going to do is we find a number na mag-i-equal sa ating 128 if we try to raise 2 with it. So what we are going to do is try to determine that specific value. So for this case, it will be 2 raised to 7. So therefore, 2 raised to 7 is going to be 128. 28. So let me confirm that one if it's correct. So 2 times 2 times 2 times 2 is going to be 16, and 16 times 16 is no, no, no. That is 4 times 4 is 16. 16 times 2, or we could have 2 raised to ano lang, 2 raised to 7. So 2 raised to 7 now would be 128. So as you can see, we could express our value as 2 raised to 7, since it's just equal to 128. So we could say that n here is going to be 7, uh, since 2 raised to 7 is equal to 128. So therefore, we get the number of terms, which is 7. So from this, we could now determine yung ating mga terms. So we could have yung first term muna, which is 3. So yung first term would be 3, tapos we add, we multiply it by 2. So it would be 2, 3 times 2 is 6, and then um, 12 times 6 times 2 is 12, and then 12 times 2 would be um, 24, and then 24 times 2 is going to be 48, and then 48 times 2 is 96, and then 96 times 2 is 192. Since we just need 7 terms, these would be the values of our geometric progression that should end up with the value of 381 when we add them. So if we do that, to confirm, we could add these values. So we could have 3 plus 6 plus 12 plus 24 plus 48 plus 96 plus 192, and try to see kung magiging ano talaga siya, magiging 381. So it would be 3 plus 6 no, no, 3 plus 6 plus 12 plus 24 plus 48 plus 96 plus 192, and then as you can see, we get 381. So therefore, the calculated values for our terms that should end up with 381 is correct. So we have here 3, 6, 12, 24, 48, 96, tapos 192 as the terms. Okay, so that's how you go about with this specific problem. And then aside from that, we could also get yung ating geometric means. So again, it's any two terms on our geometric progression. So for an example, let's try to find the 5 geometric means between 3 and 192. So for this case, again, just like what I did in finding the arithmetic means between two numbers, we are going to find the ratio now, not the difference, to find the other terms in between 3 and 192. So we would make use of the geometric sequence formula. So it would be now a sub n is equal to a sub 1 times r raised to n minus 1. And then, since we are going to insert 5 terms in between 3 and 192, that means the number of terms is going to be 7. And then, our last value of the sequence would be a sub 7, which is going to be 192. Tapos, we could have our a sub 1 as well, kasi kailangan natin siya sa formula. So a sub 1 is going to be 3. And then we could now find for the value of r. So for this case, we are going to make use of the formula. So it would be a sub 7 is equal to a sub 1 times r raised to n minus 1. And then our a sub 7 is 192. Tapos yung a sub 1 natin is 3 times r, which is the missing value. And then n minus 1 is going to be 7 minus 1, and then 192 is equal to 3 times r raised to 6. Tapos, i-divide mo lang yung both sides ng 3 Tapos, kung i-divide natin yung both sides ng 3, it would give us r raised to 6 is equal to 192 divided by 3. Now, 192 divided by 3 is how much? So 192 divided by 3 is 64. And then from this, we are going to get the sixth root of um, our r, which is going to be 64. So if you get the sixth root of 64, so sixth root of 64, are we can we do that in here? So let's try to see the sixth root. So this is just this is just yung ating square root, but we could express it in in exponential form. We could have 64 na lang, 64 raised to 1 over 6, raised to 1 over 6, and then no, 64 um, raised to, I don't know, 64 raised to 1 divided by 6. So 1 divided by 6. So nag-ano tayo? 1 divided by 6. So it would give you 0.17. So let me just check that one sa calculator, no? So yung 6 root ng ating 64 raised to 1 divided by 6 is going to give you 2. So, iba yung value na binibigay niya dito. So, I don't know what's the problem with this one because it's not going to be 0.17. So, let's try to do it again, no? So, 64 raised to 1 divided by 6. So, again, it's giving us a different value. So, do not make use of these value dun sa ating formula, sa ating calculator dito kasi it would give you a different one. It's much better if we just get the sixth root of 64, but you could also express it as 64 raised to 1 over 6, and then it would give you 2. So, for that case, yung ating r there is going to be equal to 2. So, the ratio is 2. We could now find the 5 geometric means in between 3 and 1 and 192. So, we continue by multiplying yung first value. So, 3 times 2 is 6. 6 times 2 is 12. And then 12 times 2 is 24. And then 24 times 2 is going to be 48. And then 48 times 2 is going to be 96, and then 96 times 2 is 192. So, as you can see, meron tayong 5 geometric means that we were able to insert between those values, which is 6, 12, 24, 48, and 96. Okay? So, yan yung way kung paano hanapin yung ating mga geometric means. And aside from that class, under geometric series, we could also find for the infinite geometric series. So, this is how we define yung ating infinite geometric series. So, consider an infinite geometric series whose terms are a sub 1. So, that's the first term, yung ating infinite geometric series. And then, we also have a sub 1 times r. So, basically, we just multiply yung ating common ratio to get the next number. And then, a sub 1 times r raised to 2, a sub 1 times r raised to 3, and so on and so forth up until we get the last value. But since this is infinite, presumably we cannot determine the last value, so we could represent it as a sub 1 r raised to n minus 1 for values of r such that the absolute value is r of r is greater than equal to 1. Then the infinite series would be s is equal to a sub 1 up until a sub 1 r raised to n minus 1, and meron pang mga values after that one, will not be finite. And in fact, if r is greater than or equal to 1, S will tend to be positively large. For let R take real values between negative 1 and 1. Clearly, if R is equal to 0, S is equal to A sub 1. Suppose we take, let's try to have an example. Suppose we take a value of R between 0 and 1. Specifically, we let R is equal to 1 half. Then, as you can see, let's say, ini nga aton 1 half is the common ratio that we multiply to our A sub 1. And then we raise it to a value greater than or equal to 1. So we are going to start with 1. So 1 half raised to 1 is going to be 1 half, which is 0 0.5. And then the next number is 2. So 1 half raised to 2 is going to be equal to 1 fourth, which is 0 0.25. And then 1 half raised to 3 is equal to 1 over 8, which is 0 0.125. And so on and so forth. We can observe that the value of 1 half raised to n gets closer to 0 as n gets larger and larger. So as you can see, yung ating R, if we strictly make our R in between negative 1 and 1 for that specific value that we raise it to, we can observe that the value of our n here would be now, or 1 half raised to n is going to get closer to 0 as we increase the value of R. And it's the same thing if we take a negative value. Let's say we assume yung ating negative value is going to be negative 2 raised to 3, and we do the same thing as what we did dito, wherein we strictly have values of R between negative 1 and 1. So if that's the case, then we could raise it to 1 first, kasi yung absolute value of R natin is greater than or equal to 1. So it would be negative 2 thirds raised to 1 is equal to negative 2 thirds, and you get negative 0.6666, and then yung negative 2 raised to divided by 3 raised to 2 is going to be equal to 4 over 9, which is 0.44, and then negative 2 over 3 raised to 3 is going to be equal to negative 8 over 27, which is negative 0.2969, 62,96296. And if we continue the process, as you can observe, nagpa-fluctuate lang yung ating values um, from negative to a positive one. But this value is going to still approach the value of 0 as our value of n gets larger and larger. So as you can see, if we strictly do that to our terms on our geometric series, kasi ito could be terms on our geometric series, um, we can observe na it tends to get smaller yung ating value that we would add. Kasi, as you can see, if we start with 1 half raised to 1, it's just 0 0.5. And then, if we take another value of n, it will be 0 0.25. So, it gets smaller and smaller for that case. And then, it doesn't matter na yung value that we add to our series. And we could assume na we could get a specific value dun sa ating uh, specific value for our sum of the infinite series. Kasi nga, it doesn't affect the total sum because it's very small. And then, if it's going to be the other case, na yung R natin would be now 1 or more, you could also observe that if we make use of those values, it would now gets larger and larger. So therefore, it would not settle for a specific value. Thus, it would give you infinite value. But for this case, we could actually get the value from it. So therefore, we could actually generate a formula from this. So it's better explained if it's going to be the formula now that we are going to use applied to the problem. So for an infinite geometric sequence or an infinite geometric progression, we could make use of this formula to find that specific value that we end up with. Kasi ang alam natin na it would end up with a specific value because our value of R would tend to get smaller. And then the formula that we are going to use now is going to be S sub n is equal to A over 1 minus R, where again, hindi yung ating R should not be equal to 1, or it should be not less than 1 kasi nga it has to be that r is greater than, or absolute value of r should be less than 1. So for this case, we could make use of this formula to find yung ating sum of the terms of an infinite geometric progression. So let's try to do that. Let's try to have an example involving that one. So let's say we have example 16 right here. So example 16, we have to find the sum of the infinite geometric sequence 1 half, 1 fourth, 1 eighth, 1 over 16. So how do we go about for this specific problem? Again, we could make use of the formula. Yung formula natin is S sub n is equal to A divided by 1 minus r. So we just have to identify yung ating first term. So this is going to be our first term pala, a sub 1 over 1 minus r. So yung a sub 1 there is going to be 1 half. And then of course, what is the common ratio ng ating geometric sequence? So we could actually identify that one by dividing the succeeding numbers on our sequence. So 1 fourth divided by 1 half is going to give us 1 fourth times 2. So it would give us 2 over 4. And then if we reduce this one, it's going to be 1 half. So 1 half yung common, yung ratio dito. How about for the succeeding terms? Let's try to do 1 eighth divided by 1 fourth. It would give us 1 over 8 times 4. And then as you can see, it would give us 4 over 8, which is going to give us the 1 half. So therefore, the common ratio is actually 1 half as well. So we could make use of these values now and plug it in doon sa ating formula. So S sub n now would be equal to 1 half divided by 1 minus 1 half. And again, it's going to be equal to 1 half. 1 minus 1 half is going to be 1 half. And then 1 half times 2 is going to be equal to 2 over 2, which is equal to 1. So therefore, the sum of this infinite geometric sequence is going to be equal to 1. So as you can see, even though it's infinite, we could still find for its sum. Okay? So, yan yung pinaka gist. And then, let's try to have another problem. Let's say, for example, 17, prove that the decimal 0.3333, it's non-terminating, is the same as 1/3. So what you are going to do first is, of course, we are going to express our decimal value into a series. Kasi we have to add up all of these values and then end up with a specific value, which is 1/3. So, sa ating 0.33, itong 0.3333 can be expressed as 0.3 plus 0.03 plus 0.003 plus 0.0003 plus the following values. So that could be expressed as that. So therefore, we could also express this in fractional form. So pwede ding or 0.333 can be expressed as 3 over 10, or 3 divided by 10 is 0.3. Then 3 over 100, or 3 divided by 100, 3 over 1000 plus 3 over 10,000, and so on and so forth. So we could express it like that. So if we have these values now, we could actually make use of this na meron tayo na decimal form as values that we could use doon sa ating geometric series formula or infinite geometric series formula. So we would recognize this as a geometric series by identifying the variables. So for this case, yung a sub 1 now would be our 3 over 10 kasi yan yung first value that we have. Tapos, yung ating or there is obviously going to be the value na when we divide 3 over 100 divided by 300 is the common ratio. So if we do that, 3 divided by 100 divided by 3 over 10 is going to be 3 over 100 times 10 over 3. So if you do that, you would get 1 over 10. So therefore, yung common ratio is 1 over 10. I assume sa next one would still be 1 over 10. Nag-increase lang naman yung ating uh, decimal uh, values or decimal places doon sa ating um, denominator. So, yung R there is 1 over 10. Tapos, as you can see, we could now use these values doon sa ating formula for infinite geometric series. As in, ating formula for geometric series is just S sub n is equal to A sub 1 divided by 1 minus R. As you can see, we just need yung A sub 1 tsaka yung ating R. So, it would be now equal to A sub 1, which is 3 over 10, divided by 1 minus 1 over 10. And then, equal to 3 over 10. And then, we get the value. So, 1 minus 1 over 10. So, 1 minus 1 over 10 is going to be 10 minus 1 for the numerator. So, it would be 9 over 10. And then, 3 over 10 times 10 over 9, and this would be cancelled out, so this can be reduced as well, so it would be now 1 and then 3, so therefore the value is 1 over 3. So therefore yung sum ng ating geometric series na ito is infinite geometric series, or I mean the sum of the infinite geometric progression is going to be 1 over 3. So therefore we could express our 0.333 as 1 over 3. Okay? So, yan. Yan yung pag-solve ng ating example 17. So, let's try to do another example. So, yung other example naman is find the rational representation of the repeating decimal 3.373737. So, we are going to do the same thing. We are going to express our value as a decimal number. So, yung 3.373737 natin can be expressed as 3 plus 0.37 plus 0.0037 plus 0.000037. So, yan. Tapos, meron pong mga numbers after that. So, we could express it like that. No need na yung 0.00037 plus the numbers after that one. So, we could express it like that as a decimal form. And then, after which, what we are going to do is recognize it as a geometric series. So, if you are going to recognize this as a geometric series, yung meron lang nagre-repeat dito is going to be from our 0.37 up until the last value. So, we just break this down into parts. Yung 3 natin would be separated with our repeating values. So, yung ating i-express as a geometric value now, I mean, as an infinite geometric series, or where we would get our sum of the terms is from 0.37 up until the last value. So, kukunin natin to, yung 0.37 plus 0.0037 plus 0.00037, and recognize what is going to be our A sub 1. So, yung A sub 1 there is going to be yung ating 0.37. So, 0.37, or you could say 37 divided by 100. So, yan. 37 divided by 100. Tapos, ano yung common ratio now ng ating sequence? So, yung common ratio can be determined by dividing these values. So, this is 37 over 100 for 0.37. Yung ating 0.0037 is 37 divided by 10,000. So this is going to be um, divided by 37 over 10,000. And then we get 37 over 100 times 10,000 over 37. Tapos we divide these values kasi this can be cancelled out. So we just have to reduce yung 10,000 divided by 100. And then 10,000 divided by 100 is just 100. So therefore, yung ating pinaka-common ratio is multiplying the value by 100. So 0.37 times 100 would give us um, 37 over, so it would give us 0.37 times 100 give us 3,000, no, it should be 37 over 100. So kailangan 10,000 over 37 siya. So 10,000 divided by 100 is, so it's going to be 100 for this case. So 37, I don't know, it's going to be the other way around. I'm so sorry about that one. So kailangan 37 over 10,000 kasi it would not end up with that value. So 37 over 10,000 divided by 37 over 100. And then it would give you 37 over 10,000 times 100 over 37. Tapos yung 100 divided by 10,000 is just going to give us 1 over 100. So it's going to be 1 over 100 for the common ratio. So dapat ganyan. So it's going to be 1 over 100, and it's going to be the same thing with this one, 1 over 100. And then since we just only need that, no, s is going to be now, or s sub n would be now equal to um, a sub 1 divided by 1 minus r. And then your a sub 1 there is just 37 over 100 divided by 1 minus 1 over 100. And then this is going to be equal to 37 over 100. Tapos yung 1 minus 100 natin is just 99 over 100. Tapos 37 over 100 times the reciprocal, it's going to be 100 over 99. Tapos makakancel out to, so therefore the value would be 37 over 99. So yung ating sum, yung ating infinite geometric series na ito from 0.37 up until the last value is going to be 37 over 99. But if we want to express the repeating decimal na 3.37 as a in rational form, we have to add this one by 3 as well, or to 3. So now it would be yung ating 3.37 can be expressed as 3 plus 37 over 99. And we just get yung value niya in improper fraction. So it would be now 99. Tapos 99 times 3 would be 297 plus 37, which would give us 334 over 99. So therefore, 3.3737 can be expressed as 334 over 99 as in rational form. As in rational form, I mean. So yan. I think yon lang yung mga topics on sequences and series. So what I'm going to do is i-wrap up ko na to kasi yan na yung last topic, and then I will just add another page here wherein meron tayong mga exercises that we need to work on for the following week. Okay? And then for the other class, I'm just going to upload another video for the introduction on trigonometry because advanced kami doon. For the other class, you just have to work on first yung sa ating sequences and series. Okay?